So this is learning outcome 5. So it's to apply the law of probability to find solutions to a range of problems. So that's what we're discussing today. So just to make sure that any assignment you get, you try and listen to this recording very well. So the key term today is what is probability. Probability is the amount is about estimating or calculating how likely or probably something is about to happen. So probability is just how likely something is about to happen. It could be possible. So it could be likely. When you say it's likely, that means that is most likely to happen. It's more than evens. When you say it's unlikely, it's still likely to it's like unlikely to happen. It's less than even. When you say it's impossible, impossible means that there's no chance for this to happen. Why? When you say it's certain, certain is like it will surely happen. Just like, let me give you example of like real life example. For example, now, if you want to roll a die, the dice normally have 6 faces, numbered from 1 to 6. So if they ask you what's the probability of getting numbers between 1 and 6, is certain, because a 6-sided die normally have numbers 1 to 6 numbered on it. So it's certain that we get that we get that we get number between 1 and 6. So if they ask you that what's the probability of getting 0 when you roll the die once, it's impossible, because there's no 0 in the 6 faces of the die. So that's one. So a coin too. Coin normally have head or tail. If this was probability of getting something apart from head or tail, that's going to be is impossible. So when you say expected value, another keyword here is expected value. When you say expected value, in statistics, probability analysis, expected value is calculated by multiplying each of the possible outcomes by the likelihood of each outcome will occur, then summing them together. So we'll go into more details about expected value here. So this video, if you want to check it out, you can. That's a video. That's a link to videos on YouTube. If you want to look at probability, dependent and independent events. If you want to check it, that's a video you can actually look at. So what we are going to cover today is that we want to determine probability. We want to calculate the expected value of an outcome, then probability of and normal distribution. So when you want to determine probability now, probability of an event, the number of ways the event can occur divided by the total number of possible outcomes. So for example now, say if you think about a die, when a die is rolled, there are 6 possible outcomes. Because if you look at the die now, you realize that a die will have 6 faces. So let me see, maybe I can show you. Just hold on a sec. So this is a die. This die normally have 6 faces. So these are the faces. If there's 1 here, there's 1, 2, there's 1 on the back, 3, there's 1 under, 4, then there's 5 there. So there's 1 on top, 1 under this, there's another 1 there, this and this, so making 6. And these numbers are usually numbered what? They are numbered from 1 to 6. So the probability of the die of you rolling a 4. 4 is just only one outcome out of 6. 4 is only one outcome out of 6. So if they say what's the probability of rolling 4? Because 4 is one outcome out of 6, you will say 1 over 6. The probability of rolling 1, only 1, is going to be what? 1 out of 6. The probability of rolling 3 is going to be what? 1 out of 6. The reason why it's 1 out of 6 is because 3 is just one outcome. So so there is one way of rolling 4. So, and there are 6 possible outcomes. So the probability of rolling 4 on the die is going to be 1 over 6. So this is called what? That's a theoretical probability. So in theory, if you roll a die 6 times, you should roll 4 once. That's what is happening in theory. But when you say theoretical outcome, it does not mean that that is what is obtained practically. Okay? But in theoretically, if you roll a die once, you expect to have 4 once. If you roll a die, if you roll a die 6 times, you expect to have 4 once. If you roll a die, what's it called? 6 times, you expect to have 5 once. If you roll a die 6 times, you expect to have what? 3 once. So the did for here now. If they ask you that what's probability of obtaining 6, it's going to be 1 over 6. If they tell you that what's probability of obtaining 7, it's going to be 0. It's going to be 0 because there's no 7 there in the 6-sided die. There's no 7 there. So the probability of obtaining 7 is going to be 0. The probability of obtaining 10 is going to be 0. So they can also ask you that what's probability of obtaining even number. So you check this thing that how many even numbers can you find here? You can find 2, 4, and 6. Those are even numbers. So you can find 3 even numbers there. So the probability of obtaining even number is going to be what? 3, because there's 3 even numbers there. So you write 3 over 6, which is the same thing as what? As 1 over 2. Or you can say 0.5. Again, that's it. I think that one should be okay now. If they tell you that what is the probability of obtaining number that is less than 5? When you say what's probability of obtaining a number that is less than 5? Numbers that are less than 5 include what? 1, 2, 3, and 4. So it's going to be 4 out of 6. That's the probability of obtaining numbers less than that's the probability of obtaining what? Number less than 4. Less than 5, sorry. So we move on. So probability of events not happening. Because don't forget there's probability events can happen at the same time. Are called what? They are mutually exclusive events. So for example now, a football team can win, lose, or draw a match. In a football match, the 3 possible outcomes are either you win, you draw, or you lose a match. So one outcome must happen between them, between those 3. So, but these things cannot happen at the same time. It's not possible for you to draw a match and at the same time win that match. It's impossible. So that's why they call them what? Mutually exclusive. So the mutually exclusive since it's said that one of these outcomes will happen. So the probability must add up to 1. So only one outcome of these will happen. So the 3 outcomes cannot happen one. So for example, another example is this. If you are going to school, the probability that you'll be late, you will be early, you'll be on time, must add up to 1. Because you can't be early and be late at the same time. So those probability must add up to 1. So for example now, another one is that you pass exam or you fail it. You can't pass an exam and fail that same exam the same time. So they call them what? They are mutually exclusive. Is that you pass or you fail. So the probability of you to pass and fail must add up to 1. So must add up to 1. The probability of passing and probability of failing must add up to 1. So when events can happen at the same time, they are mutually exclusive, and the probability must add up to what?